This is where the magic happens. So this is your inner mitochondrial membrane. So remember we saw the mitochondria, it was like an oval with a bunch of squiggly lines in it. Well, that's these membranes. It's like racked with it. So think of it like a server building racked with computers. And each of these is going to transfer electrons so that you can make energy through ATPase. And that's a process called chemoosmosis, or chemiosmosis, I should say. So again, one side is negatively charged, one side is positively charged. Well, you can only achieve that gradient if you have a way to move the electrons through. And you do that with these complexes, 1, 2, 3, and 4. Each has what are called Redox Centers, and they will actually take the electron paired with the proton, right? Because negative likes to pair with positive. They'll take the electron, so this becomes reduced nicotinamide adenine dinucleotide. It's such a mouthful. And it loses an electron to the system, it goes back to NAD. Then guess what? NAD goes back to the Krebs cycle and gets fed a couple more electrons and keeps coming back. So this is like this keeps going on and on and on. So the electrons pass through here, okay? And then that gives this the energy to pump protons through. And I'm simplifying this, but that's in it in a nutshell. Any excess electrons are tagged onto coenzyme Q. This is why CoQ10 is so important, or ubiquinone, some people call it. CoQ10 then brings it to 2. 2 is effectively just a depot for electrons. It doesn't really supercharge and pass protons. Moves on again through CoQ to 3. This gets supercharged, pumps protons through, and 4 pumps protons through. And then 4 is where you take whatever's left of the electrons. They go to oxygen, right? You add a couple electrons, they pick up a couple protons to match, and guess what you end up with? Water. So oxygen is the final electron acceptor of this entire system. That's why we need oxygen. Water is the waste product of this final system, okay? And carbon dioxide is a waste product of the Krebs cycle. So this is how it all works. And it's in this inner mitochondrial membrane. The mitochondria is super, super important. And the health of your mitochondria is super, super important. This is a great picture I found on, I'll tell you, it's a free online course from Harvard on cell biology. I think it was titled Mitochondria. I love these sort of artistic renderings of your cell membrane. This is supposed to show you ATPase. This actually spins in the animation, and that's how it works in the body. So as the protons drop through, it spins literally like a turbine. And what it does is it adds a phosphate group with energy to ADP, which is adenosine diphosphate, and makes it adenosine triphosphate, which is the form of energy that our cells like to use. So ATP gives us most of our energy. The proton flow from one side of the membrane rotates the turbine and adds that phosphate group to create the energy. And the rest of the mitochondrial membrane literally just exists to maintain that gradient. Okay, and it does some other things. I mean, there's some proteins that are made in enzymes and whatnot. But effectively, the mitochondria exists to give us energy. And without it, we can't do anything else. So again, why do we breathe oxygen? Because that is how this whole thing works. It is the final electron acceptor. So it'll take these electrons, right, and create the water, and this is how the chain can start again. If this was chock full of electrons and it didn't have a way to get rid of them and create this gradient, it would just stop, it would just halt. It would be like if you plugged up your exhaust in your car, it would just blow up. So you have to have oxygen as the final electron acceptor. And there's some molecular reasons why O2 likes electrons and doesn't like electrons, but effectively at the end of the day, H2O is made, which is 2 positive, right, protons, plus the molecule of oxygen. So again, your electrons, which are the negatively charged things that we use for energy, because we're really just electrical plants, the electrons move from complex 1 to complex 4 by way of coenzyme Q and redox centers, and effectively transfer the energy from what started as bread or what started as a piece of steak or a vegetable, right? And it takes the energy from that, pushes it through these membranes, creates that proton gradient, and then you get energy. Well, unfortunately, the byproducts of this is going to be some reactive oxygen species, which we already named.